All right. I'll try to use the microphone and try not to cough, but I have been sick for the last 2 days, so we'll see how it goes. So I am also from the Buffalo team, and I am Brianna Beechler from Oregon State, and there's a list of all the other people involved in the project again. And I'm going to talk a little bit about the clinical signs that we saw in the buffalo and the acute infection, so the beginning of what Ava talked about. We're a little bit out of order here. So I will go through this really quickly because we've heard it all twice and are going to hear it one more time today. Foot and mouth disease is in African buffalo. SAT 1, 2, and 3 are endemic. And typically, the only thing that's different here is people say that buffalo are subclinically infected, that African buffalo don't exhibit much for clinical signs. But of course, we had a great opportunity to ask that with this study, so we just decided to look at what happened after they got infected. So the original part of the experiment, before Ava started talking about chronic today, was that we had 12 foot and mouth disease naive buffalo obtained from Chichilui. They were needle infected with either SAT 1, 2, or 3. So this is not the co-infection experiment. This is each one individually. So 4 buffalo each got each serotype, 4 with SAT1, 4 with SAT2, 4 with SAT3. The virus was prepared by Francois at OVI. And then they were separated immediately upon infection and kept in separate bomas so that there wasn't cross-transmission from an SAT2 into an SAT1. And then on day 2, we took 12 FMD naive buffalo, 4 per group again, and introduced them into each group. So there's 4 naive and 4 infected in every group. And then we monitored them at day 4, 6, 8, 11, 14, and 30 for clinical signs and a couple other parameters. These are not the bomas the buffalo were in. This is the transport boma, but I don't have a picture of them in their bomas, so they were separated, I promise. All right, so what parameters did we measure for clinical signs? First thing we did, of course, along with all the other things that PerBright measures, the only other bit of foot and mouth disease virus I'm mixing into this presentation today are the viremia results, just to show that transmission occurred and what it looked like. We also measured body temperature, so we put intraruminal temperature loggers in every buffalo, and they wirelessly send us a body temperature every 15 minutes, and so we could see if they mounted fevers or not. We also looked for the presence and absence of mucosal lesions at every sedation event, obviously not in between sedation events, the buffalo would kill us. And then we looked at acute phase proteins. So acute phase proteins are just non-specific markers of an inflammatory response. They're not specific to any disease, but there's some evidence in cattle, actually a lot, that they go up post-infection, and that correlates really well with clinical sign development in cattle. So we asked if that happened in buffalo. And then 2 inflammatory cytokines that we measure quite frequently in buffalo, so we know they work and we have the reagents. They're TNF-alpha and interferon gamma. So just looking to see if there was an inflammatory immune response. So what happened after infection? It went great. Acute infection went as planned. There was no surprises, which is fantastic. So the contact buffalo were all rapidly infected. All of our needle-infected buffalo got infected, and there was no cross-transmission. So the SAT1 contact buffalo had the appropriate SAT1 virus, SAT2, etc. So everything went according to plan. And you can see the viremias down there, as measured by PCR, by Ava. And so in the needle-infected, the graph on the left, they're all pretty equivalent. SAT 1, 2, and 3, the viremias they mounted were all together and quite nice. Of course, there's some difference in the contact infected because there's probably a difference in dose and when they were infected, on what day they sniffed enough virus, etc. And so SAT 1 looks pretty similar, but SAT 2 and 3 do have lower viremias in our contact infected individuals. Yeah. Okay. Oh, one other thing I was going to say there. Oh, too late. How do you go back? Yes. Okay. And so the other thing I was going to say here is that this information is going to be used in the next presentation by Anna and Jan, where we actually use this to directly measure some transmission rates that they will then model and talk about what that means at the population level. Okay, so did they have oral lesions? This was a question someone asked. And these haven't been sequenced yet, so this is based on visual diagnosis only. And so SAT 1, 2, and 3, you can see that there was 5 animals that had them, 2 of the contact infected and 3 of the needle infected, but they were very small. That's a picture of a lesion that Ava gave me, and I put an arrow on there so you could actually see it because it's so tiny. So they did have lesions, but they aren't like the big, stereotypical cattle lesions that we all love to put pictures of up. So then that begged the question of then what's happening serologically, what's happening in these acute phase proteins and these other things that are linked to lesion development in cattle. And so we looked at haptoglobin and serum amyloid A, and this is the haptoglobin graph. And just to save us some time later, all of my graphs are set up like this. So we have needle infected on the left, contact infected on the right. Yes. And then you have the days on the x-axis and the nanograms per mil on the y-axis of whatever protein I am choosing to speak about at that moment. So this is haptoglobin, and you can see in the needle-infected buffalo, it is quite elevated, and in the contact-infected buffalo, it is also elevated. This is what struck me as I went and looked back at some cattle papers where they'd measure this post-infection in a similar situation, not SAT types, I think it was FMD maybe. And the levels are really similar, like they're almost exactly the same. And so they're mounting almost the same inflammatory response as in haptoglobin production. And so what about SAA? Same thing, goes up quite convincingly. Every point is a data point, just so you can see the range, but the lines are at the mean. And so then I wanted to ask, well, does the peak differ between those that were needle infected and contact infected, the size of the peak, or between SAT 1, 2, and 3 by the 3 viruses that we use, which Francois just said out loud about 5 minutes ago? And the answer is, for the most part, no, with a few exceptions. So this is the magnitude of the response. So the difference between its peak and its baseline for every individual animal, and then what's up there is the average and standard error. And so on the x-axis is animal group. So SAT1 needle infected, SAT1 contact infected, SAT2 needle infected, SAT2 contact infected, etc. And you can see that for most of them, they look pretty similar. The only statistically significant difference on there is that SAT3 needle infected and contact infected, but there's huge errors on that, and that's based on 4 animals. So what that means, I don't know, but it's there. Okay, what about fever? I said we measured fever. So I haven't finished this analysis yet. It's actually kind of complicated because we had to clean the data up. But in SAT1 needle-infected buffalo, all of them developed fevers. The magnitude of the fever response or the length of the fever response I don't have, but they're up there in the 103 degree Fahrenheit range. So they're real fevers. Some of the SAT2 and 3 needle-infected buffalo developed fevers. I'm not sure how many yet because I have to finish cleaning the data, and I haven't even looked at the contact-infected individuals yet. But they are developing fevers, at least some of them are, to be determined to what level. So what's the summary so far? Buffalo rarely develop those oral vesicles, or when they do, they're itsy-bitsy, and I have to put arrows on pictures. They do mount fever responses, and they do mount an inflammatory response as measured by haptoglobin and SAA, so just these acute phase proteins. So then I said we measured 2 other things, and these are the inflammatory cytokines. And so we measured TNF-alpha and interferon gamma. And so these are the results for TNF down here, and that's why it's bolded. And so TNF clearly went up in the needle-infected buffalo, but really there wasn't much of a response in the contact-infected buffalo. No matter how I look at this data, there was 1 or 2 animals that perhaps mounted a response, but we couldn't get curves to fit. So there's no evidence that really the contact-infected buffalo mounted a TNF response, whereas the needle-infected ones did. I also don't know what that means, but it's a fact. And so since I didn't have a peak to analyze, I did not compare the peak size for TNF. So on to interferon gamma. This is interferon gamma. And both groups, again, mounted a very similar response. Contact on the right. And when we compare the peaks, I don't think there's a difference. So they're all about the same, straight across the board between needle and contact and between SAT 1, 2, and 3 for the 3 types we used. So what does all this mean? Buffalo rarely develop vesicles, as everyone has said for years. Great. They do mount fevers, they do mount an inflammatory response, and they do have elevated cytokines. What's interesting to me in this is that although we say they're subclinically infected, because they don't develop lesions, which is true, they do have this entire inflammatory immune cascade that's occurring post-infection, including fevers, which is a bit of a clinical sign. So why they don't develop oral vesicles, but they do develop the same acute phase response as cattle is quite interesting to me and not at all what I expected to see. So what are the remaining questions? Of course, there's a lot, because there always are. So the top one is what I just said. Why does this happen in buffalo? Why do they mount these acute phase responses and these fevers but don't develop oral vesicles? And what does this mean for transmission? Since obviously some transmission is linked to clinical sign development, what does this mean for buffalo? And then those few differences I noted in needle and contact infected in TNF alpha and then haptoglobin for SAT3, is that relevant to anything, or is it just happenstance and doesn't mean anything in this situation? We don't know. Once again, the slide to thank everyone, and I'm not going to repeat everyone's names, but if I forgot your name, sorry. So these are all the thank yous, and thank you.
Thank you. Mm-hmm. Questions?
Thank you. Very interesting. Maybe you answered this question already, but it occurs to me, was there any correlation between the various parameters you measured between the animals that developed lesions and the ones that didn't?
Good question. And we only had 5 animals that developed lesions, so correlations are a bit visual at this point, like do I see a pattern? And I'm not sure I saw a pattern with any of our acute phase proteins, but we did see a pattern with viremia. So Ava and I were looking at it last night, and we think, this is not statistically, this is just me looking at Excel spreadsheets, that it looks like higher viremia more likely to have clinical signs. But the viremia did not correlate to haptoglobin level or to SAA level or TNF or interferon gamma.
No more questions? Thank you. And